So we've been working on linear equations all last semester. Linear means it's going to be a straight line. Now we're going to be working on exponential functions, and they're going to have a nice smooth curve to them. The equation, like for linear equations, the generic equation for that, or the formula, is y equals mx plus b. For this exponential function, we're going to be using f of x equals a times b to the x power. That's the same as, and we learned this last semester, f of x is just a fancy way of saying y. So it's the same as, you'll see it as y equals ab to the x power. It's the same thing. Okay, the a stands for the y-intercept. This is the initial amount. The a value is the y-intercept, or the beginning amount. Everyone should be taking notes right now. The b represents the base, or the constant ratio. And the x typically stands for the time. Okay, first example. Notes today are going to take 2 days. So we'll work on notes today, we'll work on a little bit tomorrow, and then you'll have time to work on your exit ticket tomorrow in class. For all of the examples today, it's going to be the same set of directions. We have to graph. Then we're going to identify the a and b. And we're also going to identify the y-intercept. And the end behavior. This is probably the hardest part of the lesson, is the end behavior. It's something brand new for you guys. But all of the examples, I'm not going to write these directions down every time we have a new example today, but each direction is going to be, we're going to have to graph the equation, identify what's the a, what's the b, what's the y-intercept, and figure out the end behavior. Okay, for 1a, the equation is f of x equals 2 to the x power. Okay, first we're going to graph this. And we're going to just we're not going to graph it with graph paper. You can, obviously. We're going to use either Desmos or use your graphing calculator. So pull one of those two things out. I'm going to use graphing calculator. So I want to type in the equation. So remember, we always go into y equals. Also, if your calculator is acting up, so those of you that you've used it for like the inequalities last semester, to clear your calculator, hit second and the plus sign, and then the numbers 7, 1, 2. That'll clear out if your calculator is doing anything weird, especially because the last time we used these, we were doing the inequalities. So hit second plus 7, 1, 2. That'll clear out anything that's in it. It'll change, like, you know how we were changing your Windows settings and stuff? So if your stuff is all messed up, just do that. Okay, go into y equals, or if you're on Desmos, remember f of x is the same as y equals. So even though this says f of x, that's the same as y equals. We're doing 2 to the x power. So we need to use the caret key. The caret is right above the division sign. It looks like the top of a house, or an arrow. So it pops it up for an exponent, and then put the x in there. The x is next to the green key right here. So 2 to the x power, and now hit graph. If you're using Desmos, you have to type in y equals Then I think it says like a to the x power or a squared. You have to hit that, then you got to reverse and delete and put in a 2. So you're going to be messing around with Desmos right now. You should get a smooth curve. If you get a straight line, you did something wrong. Okay, so we graphed it. Yeah. On the graphing calculator, let me clear it out first. Okay. So if you're in like a blank screen, click y equals. It's right up here on the left-hand side. And then type in 2 because the base here. Then to get it to go up in the air, we have to type in the exponent key, which is a caret. It's right above the division sign. And then it'll pop it up. And then the x is right next to the green key. And then if you need to put more, you'll hit the arrow over to put it back to the cursor to go down again. But hit graph. Did it work that time? Okay. Okay, now, so that's our graph. So you're going to do that either on Desmos or your graphing calculator is fine. So we graphed it. Now we have to identify the a and the b. Well, right now, it looks like it's in y equals ab to the x formula. So I can see right now that the b is your 2. So I know b is 2. I need to figure out what a stands for. Now, typically when I ask you guys this, I'm either going to get one of 2 answers. You're either going to tell me it's a 0 or it's a 1. So there's really a number right here in front of the 2. There is something right here. If it were a 0, things are touching, a and b are touching, 0 times 2. Remember when things are touching, they're multiplying. 0 times 2 would make this 0, so it's not going to be a 0 there. If it's a 1, 1 times 2 is still 2. So there really is a 1 right here. So a is the number 1. Also, to help you with that, a is always the y-intercept. So if you look at your graph, or you can go into your table. So to remember to go into a table, we hit second graph, and it'll take you to your table. If you're on Desmos, you hit the gear shift over where you wrote your equation. Hit the gear, and then you'll see a table button there. So you're looking for what the y-intercept is, 0, 1. So that's another way to tell what the y-intercept is, or it's hitting here on the graph at 1. So the a value is always your y-intercept. So a is just 1. Okay, so we did our a value, our b value. The y-intercept is 0, 1. Where it hits on our graph, it hits the y-axis right here at an +1.
So for a, you just put 0 or 0?
No, a is 1.
Oh, a is 1.
Yes. The y-intercept is at 0, 1. When you put it into HMH, I don't think HMH likes it as a coordinate. I think HMH just has you put y-intercept as 1.
Okay.
I think that's how they do it. Okay, now this is the part that's probably the hardest of the whole lesson. So we graphed, we figured out A, we figured out B, we did the y-intercept. It's the end behavior that gets a little confusing. So it's really asking about domain and range. And I know that's always a hard concept for algebra. Here's how we are going to write end behavior for this lesson. As x approaches infinity, y approaches, and then you're going to fill out the rest of this. So it's always going to say as x is getting bigger, or as it's going on forever. So if you look at the graph, oopsie, not mean to do that. Okay, as x is getting bigger. So as x is going to the right, so on your x-axis, that's your left, right. As it's going and getting bigger, what's happening to the graph is it keeps going up. So and we know this graph is going to go on forever. Like it's going to keep going up. There's really an arrow here. So it goes up forever. So it's going to hit positive infinity. So as x is getting bigger, y is also getting bigger forever. So y is approaching infinity as well. So as x is approaching infinity, y is approaching infinity. And then also we have to do the negative part of this. As x is approaching negative infinity, y is approaching So now I need to look at the graph, and as x is getting smaller. So as x is getting closer to negative infinity. So it just means as you look at this graph and it's going to the left, where is the line going? So that blue line, we call that it's just hugging that x-axis. So what y value is it always hitting? It seems to be getting really close to the y value of 0. So it's never going to actually touch 0. If you go into your table, as x is getting smaller, so as I go into my negatives, you'll see those numbers, the y values, they're getting closer and closer to 0. They just keep getting smaller. These are, scientific notation. You did this last year. These are just smaller and smaller. It's just getting closer and closer to 0. It's never going to actually hit 0, but it's going to get super, super close to 0. So we just say that as x is getting closer to negative infinity, the y is just getting closer to 0. Okay, let's try another one like that. Okay, this is example 1b. F of x equals 3 parentheses 4 to the x power. So it's already in ab to the x power. Okay, go ahead and graph that first. So go into Desmos or your graphing calculator. When I'm walking around in a second, everyone's doing this. You're not just sitting here watching me do math. So go into y equals, clear out whatever's there, 3 parentheses 4, the exponent is the x, and I want to see your graph. Okay, so you have your equation, or your graph. Then we have to state a, b, and the y-intercept. So a is your 3, the b is your 4, your y-intercept is 0, comma, whatever the a is, so 0, comma 3, and then we need to do the end behavior. So it's always going to be as x approaches infinity, y approaches something, and then as x approaches negative infinity, y approaches something. Also sometimes, sorry, we know y and f of x are the same exact thing. So sometimes it won't say y, sometimes, just so you know, it'll say f of x here. So it might say y, it might say f of x. They mean the same thing. Okay, so let's look at our graph. As x is approaching infinity, as x is getting bigger. Is this the right equation? Yeah. So as x is getting bigger, as x is going to the right, the y values are going up. The graph is going up forever, so that means it's getting closer to positive infinity. As x is getting closer to negative infinity. So as x is getting smaller, that line, that blue line, is getting closer and closer to the x-axis where y is 0. So it's getting closer to 0. Okay, you're going to do one on your own. So same thing, you need to graph it. You need to tell me what's the a, what's the b, what's the y-intercept, and what's the end behavior. F of x equals 2 parentheses 2 to the x power. Okay, here's the graph. Oh, wait, you're frozen. Sorry. Okay, the graph for y equals 2 times 2 to the x power. Okay, a is 2, b is 2, y-intercept is 0, 2. As x approaches infinity, so as x got bigger, y is just getting closer to infinity. As x is getting smaller, so as I go to the left, that y value is getting closer and closer to just 0. Questions on that one? Okay, so we're going to do example 2 now. Same directions though. It's just the graphs are going to start looking a little bit different. They're just going to go in different directions. Okay, for 2a, f of x equals -2 parenthesis 3 to the x power. Okay, go into your graphing calculator. F of x means just y. So -2 parenthesis 3, then your caret key to the x power. Okay, now you'll see that the graph is going down. So it's still exponential. It has that smooth curve to it. Okay, the a value is -2. Your b value is 3. The y-intercept is always 0, whatever a is. 0, -2. So if you look at the graph, it should be heading at -2 on the y-axis, which it is right here. Okay, now the end behavior. As x approaches infinity, y approaches. So as the x is getting larger, I want to know what's happening with the y's. Okay, so looking at the graph, as x is getting bigger, so as I'm going to the right, the blue line is going down, and it really has an arrow. It's going down forever. So if it's going down forever, it's eventually going to go to -infinity. So the y is getting closer to -infinity. It's just going down forever. And then as x is approaching -infinity, the y is approaching. As x is getting smaller, what is happening to the y values? So as I'm going to the left on the x-axis, as the x's are getting smaller, the y values are getting closer and closer to 0. Or you can go into your table and you'll see as the x values are getting smaller, you'll see that my y values, all the blue ones, are getting closer and closer and closer to just 0. But they don't actually ever hit 0. Okay, let's try another one. F of x equals -3 parentheses 4 to the x power. Okay, go ahead and figure out what's the a, what's the b, what's the y-intercept. See if you can do the end behavior. Okay, the graph should look like this. -3 times 4 to the x power is coming down. My a is -3, b is 4, the y-intercept is 0, -3, and then the end behavior. As x approaches infinity, the y approaches, and sometimes instead of saying y, sometimes it'll say f of x approaches, same thing. Okay, so as x is getting bigger, so as the x values got bigger, the y values start dropping, and it's going to keep dropping forever. So it's going to get close to -infinity. And then as x is getting smaller, as it's getting closer to -infinity, the y, or the f of x, sometimes it'll say. The y values are getting closer and closer to just 0. Okay, on your own or with the people sitting around you? F of x equals negative 3 parentheses 3 to the x power. Graph it. Tell me A, B, y-intercepts, and end behaviors. Here is the graph. And then A was negative 3, B was positive 3, the y-intercept was 0, negative 3. As x approaches infinity, y approaches negative infinity. As x approaches negative infinity, y approaches 0. Questions so far? Hopefully end behavior is getting better. Are you girls done with your conversation, or should I wait? Okay, next example. Again, it's going to be just the same as what we've been doing. F of x equals parentheses 0.5 to the x power. Okay, first let's graph that. So y equals 1/2 to the x power. One half to the x power. It's exponential. There should be a smooth curve. Okay. The a value, remember, is going to be your y-intercept. Or if you go into your table of values, your y-intercept is when x is 0. So 0, 1 is our y-intercept. So there's really a 1 in front here. It says 1 times 0.5 to the x power. So a is 1. B is 1/2. The y-intercept is 0, 1. And then we have to do end behavior. As x approaches infinity, so as x gets bigger, I want to know what's going on with the y values. So as x is getting bigger, so as I'm going to the right here, those y values are just getting closer and closer to 0. Or if you go into your table, as my x's are getting bigger, you'll see the y values, those blue numbers are getting closer and closer to 0. These are all tiny, tiny numbers down here. So y is getting closer to 0. And then as x is getting closer to negative infinity, so as x is getting smaller, so as I'm going to the left on the x-axis, the y values are going up forever. So it's going up, so it's going to positive infinity. Okay, let's try another one. F of x equals 2 parentheses 0.4 to the x power. Okay, see if you can figure out what's the a, what's the b, what's the y-intercept, graph it, and what's the end behavior. Okay, so a is 2, b is 0.4, the y-intercept is 0, 2. The graph looks like this. As x approaches infinity, so as the x gets bigger, where's my cursor? There it is. The y values are getting closer to 0. The y is approaching 0. And then as x approaches negative infinity, So as x gets smaller, the y values are going up. And it goes up forever, so it's going to positive infinity. Okay, last one we're doing today. This one's on your own or with people sitting around you. F of x equals 3 parenthesis 0.5 to the x power. Okay, here's your graph. A is 3, b is a half, y-intercept is 0,3. As x got bigger, the y got closer to 0. As x got smaller, the y values increased forever up to positive infinity. Questions on any of that? Tomorrow we'll finish with our last example, and then you'll have time to work on the exit ticket tomorrow. So for the rest of today, you can chat, you can be on your phone. Thank you.